Okay, so we're going to begin with trigonomic equations this last unit. So it's only 4 days. I am going to warn you right away. First 2 days are easy today. Next day that we have, not so easy. All right, so what we're going to first get into to this section is called radian measure. All right, so most of the time that I think all the time that you've been looking at angles, they're all in degrees, right? Now they're going to be in radians. So I'm just going to back it up a little bit and kind of explain where radian measure comes from. Now, here's a nice little grade 9 formula where we're talking about a circle. And the circumference of a circle is equal to pi times d. And the reason, or how they actually came up with pi, is if I take this formula and divide by d, pi is just equal to the circumference divided by the diameter. So all somebody did to figure out pi was measure the outside of a circle, measure the distance across it right through the center, and divide those two numbers, and they figured out that every circle that you do that to, the answer is 3.14. That's the only way. That's the way they discovered pi, and that's probably why it's labeled after a Greek letter, not like Dave's variable or Tchaikovsky's constant, because it wasn't that big of a deal, right? All they did was realize they got playing with circles, took the circumference, divided by the diameter. No matter what circle you get, you got pi. That's it. That's how they come up with pi. Now, here's how radian measure was developed. Is that the circumference of a circle is equal to 2 pi r. All right, so that's again because the radius is half the diameter, or 2 radiuses give you the diameter. All right, so what they said was, or what somebody came up with, was this thing called radian measure. And they said that, okay, 360 degrees then, because they wanted to relate pi to degrees. They said, okay, well, the circumference is 360 degrees around. And if our radius is 1, well, then it would be equal to 2 pi. And that's what they came up with, that theory. That all the way around the circle, that's 2 times pi. And if your radius is 1, then that's what you got. Now, from that, we can divide both sides by 2. And so they defined that pi was going halfway around the circle, or 180 degrees. So now there's actually a formula we can come up with that is simply a ratio. Now I'm going to make sure I wrote this the same in my note. Pretty much. And so that if you have an angle in degrees, we can find it in radians, because pi is considered radian measure. Pi is halfway around the circle. 2 pi is all the way around the circle. Because again, pi is a number. It's 3.14. All right. And so this is our formula that we're going to use right here. It's a ratio set up. All right. And again, theta is in degrees. And x is in radians. Again, radian measure. All right. So all we're going to do here for the first couple of examples, so I'm going to do example 1 here, is we're just going to convert, right? It's just converting, say, from a fraction to a decimal, decimal to a fraction. Same thing here. We're going from degrees to radians, radians to degrees. That's all I'm going to be doing. All right, so example 1. We have, take 90 degrees and put it in radian measure. So again, I'm going to use my formula here. All right, so I have, and this is A, I have 180 is equal to pi. All right, now I know the degrees. It's 90 degrees. So I'm going to put that in my ratio. And I'm looking for the answer in radians. So that's my value of x. Well, fraction equaling a fraction, which I love in math because we can get rid of it by cross multiplying. So I have 180 times x equals 90 times pi. Now here's the one time that I do not switch pi into a decimal, is in radian measure. All right. And so what I could do is, well, let's see, divide by my numerical coefficient. And x is equal to 90 over 180 pi times pi. If I reduce that fraction to lowest terms, 90 is half of 180. So this would be 1/2 pi, or as it's known, pi over 2. Often in radian measured, the pi is just left there, except for when we're solving, which we will get to, but not right now. All right, so we leave radian measure as pi until we're solving. We're not doing that right now. All right, B, same idea here, 150 degrees. Again, I'm going to use my ratio formula here. So again, I have 180 is equal to pi. The degrees we know is 150. And x again is the radians that we're looking for. All right, so again, I cross multiply. So I get 180 times x is equal to 150 pi. I'm going to divide both sides by 180. Again, dividing by my numerical coefficient here. Gone. And again, let's see, I can reduce this to lowest terms. First of all, I'll get rid of the zeros, right? 15 over 18, they're both divisible by 3, sorry. So this would be 5 pi divided by 6. Again, that's just taking my fraction here and reducing it to lowest terms. So again, that would be shifting degrees into radians. Now again, it's just, like I said, we're going back the other way. So we'll do that. See if I can leave my formula there. I'll do my best. Okay, so example 2. We'll do A and B here. So this time, like I said, we're going the other way where I have radians and I want to convert them into degrees. And so A, like I said, radians often are left with the pi in there, except for when you're solving. So I have 3 pi by 2. Now, because I'm going to use my ratio formula here, let's see here, I got 180 degrees is equal to pi. We want to know, right, radians. Now, I'm not going to put this 3 pi by 2 in there. What I'm going to do is actually convert it to a decimal. So I got 3 times 3.14 divided by 2. And I believe I get 4.71. 4.71 radians. There we go. And again, because I have a fraction equaling a fraction, I'm going to cross multiply. And again, this time I am going to use 3.14 for pi. It's just when I'm finding it in radians that I leave the pi in there. All right, so I have 3.14 times theta. That's the angle I'm looking for. I got 180 times 4.1. All right, again, dividing by my numerical coefficient here. Divide by 3.14 on both sides. And so my angle, I got 180 times 4.71 divided by 3.14. And what am I getting here? I got 270 degrees. There we go. All right, same idea for B. B, we have pi by 4. So let's see, I take 3.14, because that's what I'm going to have to do to put it in as a decimal. 3.14 divided by 4 equals 0.785. All right. And again, setting up my ratio here, 180 degrees is defined as pi. We are looking for the angle, and now I've got 0.785 here. All right, so again, I'm going to use 3.14 here when I do cross multiply. All right, so I have 3.14 theta is equal to my 180 times 0.875. Hopefully I can fit that in here. All right. And once again, I'm going to divide by my numerical coefficient here, which is 3.14. Let's see. Those divide each other out. What do we got? 180 times 0.785 divided by 3.14. And it is 45 degrees. All right, so again, all we're doing there is converting. We're looking at radian measure, a new type of measure that we're going to need for solving. We're going to get to the point in your calculator where you got to be able to switch it into radian modes. That's something you got to need to be able to do, and switch back and forth degree and radian mode. All right. Now, what do we got next here? Arc length. Okay. So that's converting. Leave that formula anymore for now. All right, so we got a formula for arc length. So again, I'm going to try to draw a circle here. See how I'm doing here. Hey, not bad, not bad. All right, so we have R1. And let's see, our radius. Whoops, I'll just call it R. And that R, we have a certain amount that we're going around the circle. That is called your A, your arc length. All right, and then we have an angle, theta in there. So let's see here. All right, you got your radius. Now, arc length, so that distance that you're going around the outside of the circle when you're not completely going around the circle is equal to x times r. Now, x is your degree or angle in radians. That's the key. So this theta here, well, that could also be called x. One's in degrees, one's in radians, and that's why we learn to switch back and forth. And r is your radius. Oh, put that in there. All right. Now it says, let's see here, we get to example 3. All right, so we'll do A and B here. If a circle has a radius of 45 centimeters. All right, so I'm going to put that in right away. 45 centimeters. Determine the arc length from the following angles. So we are, again, looking for A. How far around are we going around this circle? All right, we don't know that. And it says my x value here is 2 pi by 3. All right, now I'm lucky because it's already in radians, right? When we have a pi in there, 2/3 pi, that angle is in radians, which is good. And so I can just substitute into my formula. We have A is equal to 2/3 pi times the 45. Now let's see here. 2 times 45 is 90, divided by 3 is 30. So my arc length could be 30 pi. But again, the only time I leave the pi in there is when I'm talking about radians, the degrees in rate or the angle in radians, and I get 30 times 3.14, 94.2. And again, the arc length is in the same units as the radius, so it is in centimeters. All right, that's A. Let's check out B. B now, it says I got 125 degrees. And again, same things, right? 45 centimeters is my radius. I'm looking for the arc length. Now I want to plug into the same formula here, the A times x to the r, but my angle is not in radians. So I have to go back and do what I did before. I got to convert, got to use that formula. And so again, I'm just going to do it over here on the side. So I have 180 degrees is pi radians. I have the angle here, it's 125. I want to know the radians, x. All right, so I'm going to, again, cross multiply. So I got 180x equals 125 pi, or 3.14. So I'll write that in there. Divided by my numerical coefficient, just as I did before. And I'm getting the radians to be, let's see here. I never figured it out. All right, so I better get the calculator out. Let's see how I'm looking here. So I got 125 times 3.14 divided by 180. I get 2.18. right, so now I go back. I've got my radians here. I know my x value is 2.18. So my formula of A times x to the r, or times r, I have an x value of 2.18. My radius is 45. And so the distance around that circle, I take it and I'm getting, I believe, pretty close actually, 98.13. And again, your arc length is the same as your radius. The units are the same, so it is in centimeters. All right. Yeah, I guess that's good enough. All right, again, there's other examples you can check out there. Stop recording.